Thank you very much. Yes, I'm Franck Pachot. I'm an OAKLACE director. I'm working at DBA Services, where we do consulting, trainings, remote administration with SLAs, and we do most of the stuff remotely. So the company is based in Switzerland, but finally we have customers everywhere. This presentation, I will introduce some SQL and relational database concepts, which may be new or not for you. And my idea is to introduce them starting with NoSQL. It might look strange because NoSQL appeared a few years, many years after SQL. But if you think about it, before SQL was there, we were doing NoSQL. I mean, we were doing access with indexes to files and with unstructured data and all the kind of thing we can do today with NoSQL. And the second thing I've chosen to do for this demo, as I start with NoSQL and I want to do all the demo on the same database, I use the Oracle Autonomous Database, which has a NoSQL API in addition to all the SQL features. It has a NoSQL API, SODA, which has an API to store and get documents from the database. So I'm running here in the Oracle Autonomous Database. You can do everything the same on the free tier, the free database that you can use for life. And because I'm starting with NoSQL, I have no declarative language. I will start with a procedural language and I will run the first example on Python. I'm connecting to an Oracle database, and then I need the 6 Oracle driver to access to the database from Python. I connect to the database with a user password and the TNS name's name. And for this SODA API, I'm just calling from my connection the get SODA database, and I have access to the NoSQL API that is provided by SODA. In NoSQL, the first thing you do is create a collection. You do not talk about tables, but just collection of items. And in my example, I will create a collection of employees. Just with create collection, some specificities about the key. In NoSQL, you may have some declaration about the key, but the values, the document that you will put can be any structure, usually JSON. And this is what I will do. I will call the insert many because I have many rows to put there in this collection. And I will call the insert many with JSON. So I have a collection of employees and I will store information about employees like their name, their job, the identifier of their manager. I'm talking about identifier. That's the key that I provide in my collection. So let's fill this collection with a few information for my next examples. The idea of NoSQL API is to be very simple from the development point of view. Just, it's not a new language, it's just an API in your language where you can just put documents like I'm doing there and retrieve documents. Because it is an Oracle database, I commit because it fully supports a strong consistency with transactions. So I've put some items in my collection and I can query them with find. So my collection, find, and a filter. Soda is very powerful because you can query with anything and you use query by example API. It's not SQL. The idea of query by example is that you fill a document that is like a template for what you want to retrieve from the database. So here I'm just asking for all employees where the manager doesn't exist. I mean, for the boss who has no manager there. And if I print the content of that, I have king, because King has no information about manager. In a document, in the key value store with document, JSON document, you don't have strong constraints about what you put in the JSON. All documents can be completely different. You don't have to put all attributes. Okay, that's all I do from Python for the moment. Because I am connected with SQL.cl, the SQL developer command line, they have also implemented in the latest version a few commands to interact with Soda without any language, like listing the collection, Soda list, and I list the collection, counting items in the employee collection, Soda count. I have 14 rows there, perfect. Retrieving data with a get, and similar as for the find, query by example, I want all employees where name is Smith, and I have one there with his key and his value. And we can also retrieve by the key, which is the only efficient way in a key value store, retrieve it from the key, except we will see when we add more indexes like that. Okay, so that is perfect, that is simple, and this is why developers like this NoSQL API. You don't have to learn a new syntax. It's an object, a JSON object, where you can put all information and the key in front of it. Now I want to enhance a bit my model because I have new use case coming in my application. I don't want to know only information about the employees, but also where they work, like in which department and where this department is located. And then I will update. There is no really update in a NoSQL database. You just put the new version of the document. So I put a new version for the document with the same key. So the same as Ford analyst. I put information about the employee again, and I have added information about the department. And there you can have nested objects in JSON. Department has a few attributes like a department number, a department name. I will just written that, department name research, and a location, which is in Dallas. And I will do that for all of them because I want to get information about where they work. So some are working in department 10 with accounting, others in department 20 research. I have a department 30 about working at sales, okay? And I commit that. And now I can query information, for example, with information from the department, like this query by example. I want all employees from the employee collection where department location is New York. And that's fine. And that can be easy with query by example. But a problem comes because I have stored information about the department multiple times, and this is where I will introduce some relational concepts quickly, because here I have a problem to maintain that. First, if my department name changes, I have to change it for all employees there. So that's updating a lot of information, and that's also a risk to just forget one, and then I may have inconsistency, like one employee saying that department name is called accounting, and another employee also mentioning department 10, also accounting, but maybe another location. So there is first a risk there, and there is also a big limitation. For example, I may want to manage departments in my application before I hire anybody there. And I cannot do that here. Or if I want to do that, I have to find some tricks like putting a dummy employee to put the department there. I cannot just because the department information is linked within the employee department, and that's not really good. And then I will do my data model differently. Sorry. And for that, I will create a department collection. In NoSQL databases, in document databases with JSON, you manipulate hierarchical structures exactly as before relational databases were invented. And here I have a hierarchy from employees with department information, and I will put it in the other way. I will put in the department collection information about the department and then a list of employees. And there I'm fine. Let me just continue to insert all of them. I'm fine because information about departments, like its location, is stored only once. And then I have a list of employees there, and I can even add my empty department with no employees in JSON. This is just an empty set. And that's good. But that's good if my application has this point of view of looking at departments and then employees within the department. And basically, this is why relational databases were invented, because the idea of a database is that you store a lot of data that is shared for the whole enterprise, the whole company, and you have many applications on them with different views. You have people who manage only departments. You have people who manage only employees, and you have other people who need to see who are the employees in the department, and other who want to see where an employee is working. All those different point of views. If you use a NoSQL database, a hierarchical model, then you will need multiple databases. And that's the idea of NoSQL. You build a database for specific data access. And if you want another data access, you have to replicate it into another database. The opposite with relational databases is to put everything in the same database so that you back up only one and you have all consistency, but you can query it from different point of views. And then I will still in NoSQL, with the NoSQL API, I will start to apply this relational idea that departments and employees are different entities. Sorry, and then I will recreate the departments. So let's see first something else. I will recreate the departments and put only department information. But first, I want to show you what can be done even in NoSQL on a collection. Here, I can query the department by name, accounting, department by location, New York, even department where an employee is working. So that's still in my hierarchical structure. And I can query the execution plan because I am on a Oracle database, which tells me that for those kind of queries, basically what it does is scan the whole collection. What I want to show you before splitting my department and employees, sorry, I was going too fast on this idea. I want to show you another idea, indexing. Here, I want to index for fast access on location. I will do that with Python. And I have created an index, which I call my index on location, and the JSON path to index it. And then if I run the same query as before, I run the department for a specific location and the list of employees there. If I look at the execution plan, I can see that I have an index scan. So that's the first thing. For different point of view of queries on the collection, you can index it. But if you want to go further, and this is what I started to say a bit earlier, if you want to go further, the idea of relational databases is to split the business entity. Like I have a problem. I don't know if I have to store employees within department or department within employees. Then I will just split them. You can read a lot about normal forms. The first normal forms are gone third, and a lot. If you like maths, you can read a lot of interesting things about relational databases. But you can also keep it simple. What from the business point of view, what is a different entity, a different business object, goes to a different collection or different table. Here, departments and employees are different things. They are linked, but they are different things and they have a different life cycle. Like a department can be there even without employees, or maybe an employee can be there without any department. Different business objects. And I drop my department collection and I recreate one where I will put only information about departments. So the number, the name, and location, and no information about employees there. I have departments, I can query departments. Okay? And I will do the same with employees. So I still have my collection of employees with all those information about the department. Now that I have a collection with all information about department, the only thing I need to put in employees is the department number. And then I'm able to retrieve all other information. That's what I'm doing there, replacing the document about employees, just putting the department number. Still in the NoSQL API, but you start to see some relational database concepts like normalization, put in different tables what is a different business entity. And if you have links between them, just put information to be able to retrieve them from another one, and we will call that a foreign key. Okay, so that's a model that really looks like a relational model. And the nice thing with Soda, with this NoSQL within the Oracle database, the nice thing is that actually it is stored in tables. If I query the DDL that is behind my department collection there, Oracle stores it in a table. Not in a table with all columns, because it's a key value data store with just a key and a document. It is stored in a table with the same name as the collection, with an ID and a JSON document, just a few metadata if you want to put versions and modification date, but basically key value, an ID, and a document. Document is blob, binary large object, where you put the whole JSON, and Oracle optimize that with the OZone format, the Oracle binary format for JSON, which is compressed, optimal, can even be indexed in within, and all optimized for that. Okay, same for, so if I just described, I can see the columns. The interesting one is the ID and the JSON document. And same for employees, it is stored as well there. Okay, now I stop with the NoSQL thing. I started to introduce indexes and normalization, and now I will go further. Now that I realize that finally everything is stored in different tables, then I can put a structure on them and think about what are the attributes of the department, what are the attributes of the employees, and then really create relational tables for them. So I will create a depth table there. And this one will be a relational table, so not a key value. I will have a column for the depth node, a column for the dname, a column for the location. And just because I don't want to insert again all those values, I have them in the NoSQL, in the Soda API, and I can query it because it is stored as JSON in a table. I just can query it with the JSON table and mentioning the path in the JSON where it goes in the columns, the relational columns. And I add data types because in a relational database, you put a data type. In JSON, you cannot, everything is a character string, and then you need a convention, for example, for dates, if you want to store them in the same way. An Oracle has data types. And here I created a table. If I select from it, I can see it there. And the idea of relational databases and SQL, the idea is all there, a simple two-dimension table, because it's the easier to store and the easier to retrieve and the easier to visualize. I mean, JSON is nice to handle in a procedural program, but not really when you look at it. When you want to look at data, you often put them as tables. That's what you do if you put that on Excel, for example, on anything. So the idea is there, storing in two-dimension table, very simple, but maybe multiple tables. I've created debt and I will create employees just later. But a relational database has more than that. First, like my key value collection, I declare which column is the key, the department number. So that's not new, but here I can have multiple keys because a department can be identified with its number, but can also be identified with its name. I do not expect the same name for two departments in my company. And this enforces this information that the department name is also a key. In relational data modeling, you have multiple candidate key, and you can even add more keys if you don't have a natural one that is immutable and easy to reference later. Those are constraints, and I can add additional constraints like saying that location is not null. In relational databases, in SQL, null means I don't have a value for it, or the value makes no sense. I mean, I don't know the value, or the value is not applicable. Here, just with this simple declaration, I'm telling the database that we must always know the location of a department. So what's the point with it? Some people may think that it's more agile to allow any possible value or no value or anything like in JSON. But think about it. If from your Java code, you query the departments and you retrieve location information, and if there is the possibility that there is no location, then you have to handle it. In your code, you have to test what you retrieve. And if you do not do it, you will get this infamous runtime null pointer exception. More code each time you query it. Here, it is just one declaration that is done in the database, and my developers can query it without caring about should I test for null, should I build unit tests to check if there are nulls, should I handle the null pointer exception, etc. So the idea of SQL is to declare those information rather than check them each time you access to the data from the procedural code. Okay, because I am in a database, I can query the tables. Let me just check the question. NoSQL use also optimizer, how it gathers the statistic, number of rows, etc. Yes, here I am in a very advanced NoSQL API because it's running on a relational database. But usually, NoSQL databases do not have an optimizer. And they don't really need to because the API is really simple. Either you access to a document with its key, or you scan all documents. And then you don't need to have an optimizer. Here, I have an optimizer. We have seen an execution plan before with indexing. And here I'm showing as well an execution plan. If I query from depth, I can see that the database will access depth with a full scan. Actually, actually, what I may not have mentioned, SQL is a very special language in the sense that it is a declarative language, not a procedural language. If it were a procedural language, I would have to mention how to access to data. Start there, loop on that, access with index to that. And there you don't need an optimizer because you are doing the job to say how you access to data. Here in a relational database, SQL is just declarative. I just declare the result I want, the shape of the table I want as a result, and the optimizer will do the job to find the best way to access it. So for the moment, the access is quite simple because I have a table and no index on yeah, I have a few index, but anyway, I'm reading everything. So it is a full scan on the table. But thanks to the constraints that I have declared, if someone queries department with no location, the database knows that there are no departments without location because that was a declaration. We do not accept any department without location. And you can see something that looks like the same execution plan, but the important part is the starts colon. When I executed a simple select, sorry, I will put that, no, cannot. I will put, yeah. When I selected just all rows from depth, it had to scan depth. When I want all rows where location is null, the database didn't even start to read this table because it knows that the result is empty. This is a very simple query, but in complex queries, the optimizer can take a lot of decisions if you provide the correct constraints. It can also eliminate, for example, when you have a view on multiple tables, and it can also eliminate some access just because it knows it doesn't have to look at them. Okay, quickly, I create the same kind of table, but for employees. Again, I'm mentioning the path in the JSON to fill it with my 14 employees there. This is what my employee table looks like. And just before adding constraint there, I have to mention something. I said that I separated department and employees because those are two business entities. In this model, I consider that the employee job is just an attribute, like a description I put on an employee, as well as I declared for the location of the department that it is just an attribute. Probably when my information system grows and when I have new cases, there are good chances that I start to consider the job as a business entity by itself, with specific names for jobs and a list of skills and a lot of that. And probably I will have a table job and just an ID in the employee to tell which job it is. Same for department, I will just have an ID of the location and then probably many tables with cities and countries and all of that. Normalization, just think about what you want to manage as a business entity or what is just a small information on an existing entity. So again, I create the primary key, which is the employee number for my employees. I have another key. Sorry, do I have another key? No, the name is usually not a key, so you need an ID. And I had another constraints like the department number must be known. I cannot enter an employee without knowing the department. This is my choice, my business rules. During my business analysis, I will know if I have to enforce this rule or not. And I will add another constraints where I mentioned that not only you need to know the department number, but you need to be sure that the department number that you put there is known, exists in the department table. This is a foreign key. The foreign key references here the primary key, but it can reference any key, so a unique constraint or primary key. And I've put on delete cascade to mimic the thing that I had with my department collection where employees were stored within the department. And let's take an example. I have 14 employees there. I delete one department, and then all employees in this department are gone. You choose that. You ask the business what they want. I don't have that because I stored it as a hierarchy. there you have no choice. I have that because I decided about this on-delete cascade, which I can change. Probably I don't want to kill the employees if a department is not there anymore. And then I just don't want to remove a department where I have employees in them. Something we have in relational databases. We work on transactions, and if you do not go until the end of the transaction, we can cancel them with rollback, and this is what I'm doing here to do the same example from the beginning. I will drop the constraint and create it without mentioning on-delete cascades, which is the equivalent of on-delete restrict, which is not really in the vehicle syntax, but that's the default. And there, if I delete department, I just cannot, and it tells me why, because I have child records there. Okay, that was quick to mention that you can store hierarchies in a relational database as multiple tables with foreign keys, and you have the choice to manage the hierarchy as an aggregation or a composition where you have this on-delete cascade or not. In a NoSQL database, if you remove a document, you remove all the information that you have within it. And because we have multiple tables, we have to join the tables. So SQL is declarative. I just declared that I want everything from employee table and joining to department. It may be obvious that I want to join on department number because you have seen that I have declared a foreign key. But the idea of relational databases is that on your data model, you can query in very different ways. And then the way you join it, you declare it at runtime. Here, I am interested to look at department with employees and ordered by employees, and this is the result. And again, this is not as it is stored, this is the result of the query, but again, two-dimension table, which is easier to understand and to read. We will see later that maybe in a report, you don't want to put all information in all lines when they are repeated. But the idea of relational databases is that a row, if you take only one row, it has a meaning by itself. If you take only the rows and you know the columns, like you can read that like employee number 7782, who's called Clark and works as a manager. As a manager, yeah, as also a manager was hired on 81 and is working on accounting department, and this department is in New York. You can really read each row as a sentence without having to look at the other rows. So that's the powerful of two-dimension table visualization. And it seems there that you have redundancy, as I had before when I stored everything in the employee collection, like seeing research there, research in Dallas. But this is only linked, joined at runtime. If, in this case, if I want to update the name of a department, for example, the department sales is now called cloud sales. I just do one update. I don't have to go to all records behind. I just update one. And when I select the same thing with the join, I can see that I have the updated value everywhere. All is consistent without caring about where they are referenced. So that's the power of relational databases and SQL. Let me look at the time. Yeah, that's going fast. I will join now from depth to employees, and I order by department. Actually, what I want to show is the list of departments with employees in them. If I want to put that in a screen or a report, probably I don't want to repeat all those information. They are repeated by default just because of this easy visualization. If you take only one row, you have all information. But first, because it was ordered, in the network, it was not sent multiple times. It was compressed. And in the visualization, in my client tool, I can decide to display only one time. But this is only a display. SQL, relational databases, prefer to show everything as a two-dimension table. Like you do in Excel. I mean, in Excel, for example, when you have everything in a row, you can put all formulas that you want. If you start to show it like this, formulas will be a bit more difficult to do. And I mentioned that the join is done at runtime, so you have to put the join information at runtime because you may want to see different things. For example, here I have the list of employees per department, but I may want to see the information that there is a department without anybody in it. And in SQL, it's just one change in my declaration of the result I want. Left outer join means that the table on the left, the department, may be there even if we have nothing else there. What I want to say there, while I'm doing the same and breaking on jobs, is that I can show information in any way I want from the same database. I don't have to build another data model, another key value data store, just because another kind of users want to list the employees per job. I can query it this way from the same tables because of SQL declarative language, because of normalization, and because of relational databases. Okay, just showing very quickly that you can also show information as JSON. If this is the thing that the application expects, you don't have to store them as JSON. You can show them and exactly in the way that you want. For example, 4 JSON documents for my 4 departments, or lists of employees with a department name, or the role as a JSON, and you can also pretty format it. I'm showing that while I'm reading the question. Anything changed with last version? As the demo reminds me of the 733 days, please. Yeah, for example, these JSON queries are new in recent version, but I'm showing the basis of SQL, the basis of relational databases, and yeah, this AMP and depth can work on very old databases. And those examples I've taken depth and employees are coming from the examples that were there in very early databases. They were nearly the same in Oracle 2, for example. Okay, for the 5 minutes remaining, I will just skip a few things to mention something very important in my opinion if you are new to SQL or if you know SQL. There are actually 2 kind of SQL languages. Let me just do a query to show you what I want to tell you. Here, I did a select star from AMP, and I've put hard-coded values there. This is okay only because I'm doing some interactive stuff there. So the kind of thing that you can do as a data scientist in a Jupyter Notebook, for example, or in ad hoc queries generated from a tool. But if you code from a program, you don't want to select all columns. You want to know which columns you will get there, because you don't want a runtime exception if one is missing or one additional more is there. And you don't want to hard code the value. Just let me show you in programmatic version of SQL, you bind values, which means that basically you don't do that. Running the same kind of query with different values, because I just want information about different employees. This is okay when you do it interactively. This is not okay in a program. In a program, exactly like with any program, you put the code, you compile it, and then you execute it multiple times with multiple values. And the same with SQL. I put my SQL code in a character string there. I compile it, and this is called prepare in SQL. And then I run it with multiple values. And I have exactly the same result, but it is more optimized and safe. Also, it's safe because I do not risk any SQL injection there, because you cannot change the semantic of the query when you change only a value in a variable that is declared before. Okay, I will now show you how to do more on this demo, and also to reproduce the demos that I've done today. Just let me leave that and put a link on the screen. You have here a QR code, and which goes to this URL. And this is a Jupyter notebook where I've put all the queries I've run there. You can, this Jupyter notebook is on Colab. So if you have a Gmail account, for example, you can run it and run whatever you want. It connects to my database, but you can use it. And you can also create your own autonomous database if you want to do the same. Just let me show you how this notebook looks like. If you go to the SQL 101, it redirects URL that is there. It redirects you to this page where you have everything. So this is the handout for this session. Just run the cells that connect and download all the tools to connect to my database and the credential, of course. And those are all the examples I have shown. There are even more about transactions and doing stuff in multiple transactions. And you can really run it. You can run all. You can change a query and change something in it and run it. You can play with it. It's on my autonomous database. If you don't put too much data, everybody can use it without any problem. Do you have any questions? So I just put again this. So there is a lot in SQL. My idea is to show that SQL is not complex. And what I've done today is basically what was done when SQL was invented. And the first paper about SQL as examples very similar with employees and departments, and show that SQL helps to solve a lot of problems where you need less code in your program procedural language. And queries like, for example, I didn't have time to show you, but in the notebook, for example, there is somewhere where I show you the managers who earn more than the employees who earn more than their manager. And that's not easy to do with procedural language. And that's easy with a join, where you just join employee with employee, but with different role. You read the list of employee as employees, and you list the list of employees as managers. And this is why you need this join clause at runtime, because you don't always join with something obvious like the foreign key. Here I am joining on something else because I want something different. And then I just compare from those two sets of managers and employees who earn more than the others. Okay, I think we are just in time. Let me see if there are some questions.
Yeah,
And tell me
already.
if we have time for questions or not.
Yeah, we have 5 minutes. If you have questions, you can write them in Q&A sessions.
And if you don't have questions, this is my Twitter handle, Franck Pachot, and in the notebook, there is also my email and many ways. One question from Gabriel, can you comment why use NoSQL database? So you got the idea of my message. I start with NoSQL to show that finally SQL is more powerful than NoSQL. So basically, most of the time, I think that it's better to start things with SQL because it's more powerful and it was invented to overcome some limits. But if you have something that need to scale, but that scale like Facebook, like Google to millions of users, having a relational database and an optimizer and complex query handling can be more difficult. NoSQL databases, because they provide very simple APIs and maybe no transaction consistency and no joins. NoSQL databases are much more easier to code and to optimize. And then if you need this level of scaling, a NoSQL database can be okay. But don't think it's more agile. You need to know exactly how your application will use it. I access with a key to a value and always the same, and then it can make sense there. Okay, no more question. Perfect.
Yes,
Do not
thank you
hesitate.
so much for being with us on this tour.